Yeah, hello guys, you're welcome to my channel. Today we want to look at another integral question, and the question is on the integral of e to power of arc cos of x dx. Like we have in our other video, we are asked to choose the method we prefer when we integrate the square root of 1 minus x squared with respect to x. So a lot of people, they prefer the trig substitution to the integral by parts. Okay, today we are going to look at integral by parts and u substitution. Then you can tell me the one you prefer. Now let's see how it goes. Now if you look at this question here, we are dealing with a two transcendental function, and the two transcendental function are such that they are like a function of a function to each other. So automatically this integral might be a bit difficult, but absolutely we are going to crash it out. Now let's see how it goes. Using the integral by part first before the u solve, I'll say let u equal e to power of arc cos of x, and I have that dv is equal to dx, like this. So I will differentiate this. I will have the u to equal negative e to power of arc cos of x divided by the square root of 1 minus x squared dx, like this. And when I integrate this, I will have that v equal what? X, like that. I believe we understand that. This is a function of a function. When I differentiate arc cos of x, my result is going to be 1 all over the square root of 1 minus x squared. So multiply by the derivative of the entire function, which is going to be the same thing because it's an exponential function. Do we understand that? Okay. Now, if I integrate the v, my result is going to be v. If I integrate the x, my result is going to be what? X. Are we together? Now, let's substitute this into what? Into the equation. Don't forget that this is equal to what? I. Hence, I will have that I is equal to uv, that is this times this, that's x e to power of arc cos of x, minus the integral of v du, and that's going to be negative x e to power of arc cos of x divided by the square root of 1 minus x squared dx, like this. Okay, if this is what we have on the board, then it means there is need for us to integrate this part again. Now, let's say this place is equal to I2. So, I2 equal the integral of negative x e to power of arc cos of x divided by the square root of 1 minus x squared dx, like this. Are we together? Now, if this is what we have, how can we differentiate this? We are going to what? Integrate this rather using another what? Integral by parts. Okay, now in this case now, I will set my what? E to power of arc cos of x to equal what? To equal my my u, and I'm going to integrate minus x divided by the square root of 1 minus x squared dx. Are we together? So my u from here is going to be e to power of arc cos of x, and my dv is going to be negative x divided by the square root of 1 minus x squared dx, like that. Okay, if that should be the case, I2 will become this. If I differentiate it, I'm going to have the du to equal negative e to power of arc cos of x divided by the square root of 1 minus x squared. And when I integrate this, I'm going to have the square root of 1 minus x squared, like that. Okay, so it means that I2 is going to become uv, that is the square root of 1 plus x squared, 1 minus x squared, then multiply by e to power of arc cos of x minus the integral of this and this. When you use this to multiply this will cancel. Are we together? Then we have what? Negative e to power of arc cos of x, like that. Okay, if that should be the case, I can say that I2 equal what? the square root of 1 minus x squared. Then I have e to the power of what? Arc cos of x minus this minus, if it multiply this, it become what? Plus. Then I will have the integral of e to the power of arc cos of x dx, like that. But if you look at this, you're going to see that it is the function that we started with. Hence, I2 will become the square root of 1 minus x squared e to the power of arc cos of x plus I, like that. So we are going to substitute this in place of what? I2 here now. So this result will be substituted in place of what? I2. So I will then have that. Okay. So I'm going to have that I, which is this, is equal to x e to the power of arc cos of x, the minus the value of this, so the square root of 1 minus x squared e to the power of arc cos of x, then minus I, like that. Okay, if that is what we have, we are getting to the end of the game like this. So integral I, the I will come to the other side, then I have what? I plus I to equal x e to the power of arc cos of x, then minus the square root of 1 minus x squared e to the power of arc cos of x, like that. Okay, this is going to give us 2i, so we have that I is 1 over 2 into x e to the power of arc cos of x minus the square root of 1 minus x squared e to the power of arc cos of x, like this. So e to the power of arc cos of x is common. Let's factorize it out. Then we'll call it all, like that. So the integral of e to the power of arc cos of x dx is equal to 1 all over 2e to the power of arc cos of x into x minus the square root of 1 minus x squared plus c, like that. And that's going to be the result using the integral by what? Integral by parts. Now let us now try the u sub and see how it's going to be. Now I saw this question on Dr. Paya's page, and when I watched the video also, he said what? We cannot use what? U sub, or probably he said it's difficult. Maybe I couldn't get him right. Okay, I'm going to drop his link. Then you can find the link to his video in the description box below. Let's see how to use the u sub in solving this particular question. Now, if you want to know if you are right or wrong, you can just differentiate this. If your result is this, then we are right. Okay, you can do that at your what? Leisure time. So let's quickly look at the u sub, and I think you are going to learn something new in that aspect. So using the u sub, if this is equals to I, then I can say let's, instead of u this time around, because of what you are going to encounter on the road while going with this, then let's say w. Let w equal what? Arc cos of x, like this. So if w is arc cos of x like this, then I have that x is equal to the cos of w. Okay, so if that should be the case, the x is going to become what? Negative sine of w, the w, like that. Okay, if I have this now, I can now substitute this here. So I have the integral of e to power of w. Instead of the x now, I will have what? Negative sine. Okay, let me put the negative out here. So I will have negative sine of what? W dw. So this will be the question here now. Okay, for us to continue here now, we have to also bring in integral by parts, because we cannot solve this like this. You have to what? Part it as well. Okay, if that should be the case, I will say let our u equal what? E to power of w, then our dv to be negative what? Sine of w dw, like that. So the u is going to be e to power of w dw. Then we have what? V equal, if you integrate negative sine of w, we have what? Cos of w. Hence, this integral, that is this particular one, integral, negative integral, okay, let me say negative e to power of w sine of w dw is equal to uv, that is cos, okay, cos of w e to power of w minus the integral of v du, and that is going to be e to power of w times the cosine of w dw. Okay, if that should be the case, it means now we have to integrate this again. So if we are going to integrate this again, we also employ what, the integral by parts. So let's quickly do this one somewhere here. So we have the integral of e to power of w cos of w dw, like that. So we let our u to equal what, e to power of w, then we have our dv to become cos of w dw, like that. Okay guys, this is going to give us that the u is equals to e to power of w dw. Then we have v equal integral of this will give us sine of w. So the integral of this function e to power of w, then cosine of w dw is going to become this and this, that's e to power of w sine of what, w, minus the integral of this and this, and that is going to be e to power of w, then sine of okay, let me write this here because of space, minus the integral of e to power of w, then sine of w dw. Okay, so we are going to substitute this into this, hence we have that the integral of, okay, let me put this negative out here, so e raised to power of w sine of w dw equal the cosine of w e to power of w minus, this will go minus what, e to power of w sine of w, then the minus will affect this to become plus. So we have plus integral of e to power of w sine of w dw, like that. Okay, if that is what we have there, guys, now we can continue and we are almost done. Okay, it seems it's getting boring because of what, it's too long and it's a bit tasky. So if you look at what is here and what is here, it's the same thing. So let's collect the like term. Okay, so I will have, let me call this one I. So I have what, 2i to equal what, the cos of w, then e to power of w minus e to power of w, or let me say minus sine w, then e to power of w, like that. You know, this already come down here, hence I will have that I is equal to the cosine of w e to power of w minus sine of w e to power of w, all times half. Okay, if this is what we have, then let us recall what we started with. Cos of w is the same thing as x, so I can say this is going to be what, x times e to power of w is the same thing as saying the arccos of x, so this is arccos of x, then minus sine of w is the same thing as saying the square root of 1 minus x squared, since sine of w is equals to the square root of 1 minus cosine square of w, and cosine square is going to become what, x squared, hence the sine of w become what, the square root of 1 minus x squared, then multiplied by e to power of arc cos of x, like that, all multiplied by what, 1 over 2. Okay, guys, we are there already. So remember, this is negative integral of e to power of arc cos of x dx, like this, equal this. Okay, don't for us not to waste time, let's just multiply through by that, by negative. So this will become the square root of 1 minus x squared e to power of the cosine, the arc cos of x, then minus x e to power of the arc cos of x, then everything multiplied by 1 over 2 plus c. And that is our result. I think we have the same thing as what we did earlier. Okay, and that's that about that. So you can tell me the one you prefer out of the two methods. Is it the use of, or you prefer that of integral by parts? So that's it about. Okay, I can as well factorize out e to power of arc cos of x. I'll still have the same thing like that. So let's factorize it out. Then we get the same result as the previous one. Now let me leave you with another integral to practice. Okay, so let's have another integral to practice, and that will be the integral of the x divided by 1 minus e to power of x, like this. So you can give this a try and tell me what your result looks like, and we catch fun with that. Thank you for watching. We'll meet in the next class.